Now we take integration by substitution. See, regular problems, when you cannot work out by previous formulae, the previous formulae are to be modified and by substitution. Then they can work out. We can work out problems, slightly complicated problems. So, first of all, the same set of formulae which we have done earlier, we shall try to modify. First formula is, say, integral ax plus b whole power n. Earlier what we have done, x power n dx we have done it. So x power n is what? X power n plus 1 by n plus 1. Here power n is there and bracket is there. Instead of having a linear expression in the bracket. So that expression, if it is in the x power n, we can do it. So we take, let t is equal to ax plus b. So a little differentiation also we did. dt, derivative of t, is equal to a into derivative of x with respect to x is what? 1. And derivative of b is always equal to 0 into dx. Why dx? Here dt is there, dx we have taken, derivative of x. So dx is equal to dt by a. So what do you get here? This is equal to integral, this is what? T power n. Dx is what? dt by a. dt by a. So 1 by a you take out. T power n with respect to t. When you integrate, t power n plus 1 by n plus 1 plus c. Why? Because x power n dx is what? X power n plus 1 by n plus 1. T power n dt is what? T power n plus 1 by n plus 1. But t we have assumed, so t value we have to substitute. 1 by a into n plus 1, which is there already in the denominator. T value is what? Ax plus b. So ax plus b whole power n plus 1 plus c. So this is b here. So where n not equal to minus 1. If n is equal to minus 1, what will happen? The denominator minus 1 plus 1 will become 0. 1 by 0 is what? Infinity. So there is no problem at all. In the same manner, number 2, say what you can do, something power n is what? Something power n plus 1 by n plus 1, and that differentiation of that particular thing, that is the ax plus b, can be written as a, that a is written in the denominator. In the same manner, integral one dx by ax plus b is equal to dx by something is what? Log x. So log of this one, so we write log of ax plus b, and then that tail, that is what? 1 by a plus c. Why we are writing the tail? If we put t is equal to ax plus b, this t is equal to x plus b means what? Dt by a is equal to dx. So this is what? Dt by a by t. 1 by a you take out. Integral dt by t is what? Log t plus c. T is what? Value you substitute and you get back this one. Third one, integral dx by root of ax plus b. You know, integration of dx by root x is 2 root x. Integration of dx by root of something which is linear expression can be written as 2 root of that expression, and then by a. That a, you know, dt by a you come across, therefore 2 by a plus c. So we take up fourth formula, integral e power x dx was there. So here we take e power ax plus b with a linear expression in the new power. So this is nothing but e power something is e power same thing into 1 by a and then plus c. Number 5, integral sin ax dx. Integral sin ax into dx. So sin x dx is minus cos x. So sin ax, sin of something is what? Minus 1 by a cos ax plus c. See, sin ax plus b also can write minus 1 by a cos ax plus b. So whenever it is required, we do it, otherwise not. Number 6, integral cos ax into dx is what? In the same manner, integration of cos x is sin x. Cos ax is what? 1 by a, the tail. You have to return sin ax plus c. Number 7 is integral secant squared ax. If you differentiate something, you get secant squared, so that is what tan. So secant squared ax is there. There earlier integration of secant squared x dx is what? Tan x. Here it becomes tan ax into 1 by a plus c. Similarly, we have got 8th one, integral cosecant squared x, cosecant squared ax into dx. Cosecant squared x is what? Minus cot x. Cosecant squared ax is there. The tail you have to write, that's all. Minus 1 by a cot of ax plus c. Next, 9th, integral secant ax into tan ax into dx. So integration of secant x tan x is what? Secant x. The secant ax tan ax dx is what? 1 by a. The tail you have to write. Not 2 times, only once. Number 10. Same manner, integral cosecant ax into cot ax into dx. The dx should not be forgotten. Minus 1 by a cosecant ax. Why? Cosecant x cot x integration is nothing but minus cosecant x. Here cosecant ax cot ax into dx is there. Minus 1 by a, the tail 1 by a into cosecant ax plus c. Number 11, you see, integral dx by root of a squared minus x squared. You have got, see, put a star mark for this. The tail for all these problems, formulae, 1 by a is the tail. Here 1 by a you don't come across sin inverse x by a plus c. Because when you differentiate sin inverse x by a plus c, you get 1 by root of n minus 1 by root of a squared minus x squared. Eleventh one, 12th, actually you come across that 1 by a once again. Integral dx by a squared plus x squared is equal to 1 by a into tan of x by a plus c. Here you can see not only 1 by a, but here instead of writing tan inverse x, x by a should be written. If you want, you differentiate the right hand side and see whether you get the left hand side or not in the integral. Okay, so this is the thing that you come across.